So we're going to begin Module 9 today. Module 9 talks about something called trigonometry. But before we get into talking about trigonometry, we're going to do a little bit of review of the Pythagorean theorem and learn a couple things about the Pythagorean theorem that you've probably never learned before. The Pythagorean theorem relates the lengths of the hypotenuse and the legs of a right triangle. The Pythagorean theorem is a squared plus b squared equals c squared, where c has to be the hypotenuse. And a and b are both legs. The hypotenuse of a right triangle is opposite the right angle. So let's do number 1. Number 1 says, use the Pythagorean theorem to find the value of x. So the first thing that we need to do if we're going to find the value of x is we need to identify the hypotenuse in this right triangle, because the other two sides will be legs and they can go in for either A or for B. So here's my right angle. Opposite that right angle is the hypotenuse. So when we do a squared plus b squared equals c squared, what number has to go in for c, or what letter? X has to go in for c. Can be a number, can be a variable. So x, and then we square it. So what are we putting in for a and for b? 17 and 7. Does it matter which one we put the 17 in and which one we put the 7 in? No. We need 17 and 7 for a and b, so I take the 17 and I square it, plus, and then we take the 7 and we square it. And now we're going to need some calculators. What is 17 squared? What is 17 squared? 289. Plus, what is 7 squared? 49. And then we need to add the 289 and 49 together, which gives us 338. So 338 is equal to x squared. How do we get rid of the squared here? What operation undoes a squared? Square root. And if you do it to one side, you have to do it to the other side. So we're going to take a square root of both sides because we need to get the squared to cancel out. So we cancel the squared and the square root over on the right side, but on the left side the square root doesn't cancel because nothing over there is being squared. So from here, we've got one of two different things that we can do, and depending on the problem and the directions on the problem determines which thing I would do next. I can either take the square root of 338 and just put it into my calculator and get a decimal approximation. But a lot of the problems that we are going to be working on require an exact reduced radical. So we're going to take this square root of 338 and we're going to put it into reduced radical form. Square root of 338. In order to put it into reduced radical form, I have to think of what things will go into 338. And I want it to only be prime numbers, numbers that are only divisible by 1 and itself. So numbers like 2, 3, 5, 7, but not 4, because 4 is not just 1 times 4. That's not the only thing that I can multiply to make 4. I could also do 2 times 2, so that's not a prime number. I don't want 6. 6 is not a prime number because I could do 2 times 3 to get 6. A prime number is a number that you can only get by doing 1 times itself. Yes. What'd you say? 13 is a prime number, yes. That's a good example. 11 is another prime number. Is 9 prime? No. So I usually start with the smallest prime number I know of, which is 2. Does 2 go into 338? Yes. What do you get if you do 338 divided by 2? So 2 times 169 is the exact same thing as 338. So underneath my radical, I have 2 times 169. Does anybody happen to know what goes into 169? Will 2 go into 169? No, 2 won't go in because it's not even. Dara, what was that prime number that you told us a minute ago? Absolutely, 13 times 13 is 169. So we could do 2 times 13 times 13. That's exactly the same as 338. What do we normally call it when we take something times itself? If you do a number times itself, what do we call that? Squared. So when I have this 13 times 13, that would be the same as 13 squared. The square root of 2 times 13 squared. When I have multiple things underneath a radical that are being multiplied together, I can give them their own radicals. So I could turn this into square root of 2 times the square root of 13 squared. And what happens when I have something that's being squared and square rooted? What happened over here when we had something being squared and square rooted? They canceled out. So the square and square root cancel out, but I still have the 13. Is the 2 being squared? No. So 13 can come out from underneath the radical, but the 2 has to stay underneath the radical. So 13 square root of 2 is equal to x. We will have to simplify our radicals unless the directions specifically say they want it in decimal form. If the directions aren't clear, then a reduced radical is how we need to write our answer on these problems. All right. Let's look at what we have here right before number 2. A Pythagorean triple is a set of 3 whole numbers so that a squared plus b squared equals c squared. In addition to being the hypotenuse, c will always be the largest of the 3 numbers. So these Pythagorean triples, if I do 3 squared plus 4 squared, what is 3 squared? 9. What is 4 squared? 16. What is 5 squared? 25. Does 9 plus 16 actually equal 25? Yes, 9 plus 16 does equal 25. So we would see that happen for any of these other Pythagorean triples that are listed. We have a 5, 12, 13 Pythagorean triple. If you do 5 squared plus 12 squared, you get 13 squared. 25 plus 144 equals 169. 8 squared plus 15 squared equals 17 squared. 7 squared plus 24 squared equals 25 squared. So across the top, these are some of the very common Pythagorean triples. Underneath each of these are variations of the Pythagorean triple that's up at the top. A 6, 8, 10. Well, that's 3 times 2, 4 times 2, and 5 times 2. A 9, 12, 15. That's 3 times 3, 4 times 3, and 5 times 3. And so then down here they give what the pattern is. 3 times something, 4 times the same thing, 5 times the same thing. And here we have our 5, 12, 13, all of those variations. All of the variations of an 8, 15, 17. All of the variations of a 7, 24, 25. These are not all of the Pythagorean triples ever. This is just the most common variations that we tend to see happen. So on number 2, I want to use a Pythagorean triple to find the value of x. So on number 2, part A, let's look at this. I have a 14 right here and a 50 right here, and we're trying to figure out what would go in for x. Well, what's the hypotenuse on this triangle? Which of those pieces, the x, the 14, or the 50, would be the hypotenuse? The 50 would be our hypotenuse. All right, so let's mark that. Because it's the hypotenuse, that means it's the biggest. So I'm looking over here at the biggest value in each of these Pythagorean triples. Is 50 a multiple of 5? Yes. What would you multiply 5 by to get 50? 10. So this is either 5 times 10, or is 50 a multiple of 13? Is it a multiple of 17? Is it a multiple of 25? What times what would give me 50 here if it's a multiple of 25? Yes, 25 times 2. So one of those is going to be the key to figuring out which one of these triples we're looking at. So I know it's either a 3, 4, 5, or I know it's a 7, 24, 25. So I have to have the same pattern. Whatever x is here, x has to be the same here and here. We said 5 times 10 would give us 50. If it's a 3, 4, 5, then this 14 would either have to be 3 times 10 or 4 times 10. Well, what's 3 times 10? 30. What's 4 times 10? Neither one of those is 14, is it? Let's go to the other one that we looked at. The 7, 24, 25. Can we make 14 by doing either 24 times something or 7 times something? 7 times what? 7 times 2 would give me 14. So it's not going to be the 5 times 10. It's 25 times 2 right here. And 7 times 2. This is a 7, 24, 25. So this side x over here would have to be 24 times 2. Well, what is 24 times 2? 48. So x equals 48. You guys okay if we try another one that's kind of like this? All right, let's look at example B. First of all, what's the hypotenuse in example B? X is the hypotenuse. So I can't use the biggest number here to help me figure out which of these triples we're looking at, but I can look at the other two values and try to figure out which of these patterns this fits in. I have a 48 and a 20. Which one of those is smaller? The 20. Okay, so that would have me looking at the first number in each of these. $20 is the smallest one, 48 is bigger, the hypotenuse is always the biggest. Can I do 3 times something and get 20? Can I do 5 times something and get 20? What can I do? 5 times 4 Okay, can I do 8 times something and get 20? 7 times something and get 20? No, so it has to be a 5, 12, 13 triangle. And we figured out that the x has to be what here? We said it's going to be 5 times, what gives me 20? 5 times 4. So 5 times 4 to get 20. That means we would have to do 12 times 4. That gives me 48. Is that my other side? Okay, so we've got this one, which must mean that last number, my hypotenuse, would be 13 times 4, which is 52. So x is 52. Yes. Mm-hmm. That's what I looked at. I looked at the smallest number in each of these. In all of these sets, I looked at the smallest one. Yes. If you know the hypotenuse, then you can look at the biggest one. If you know the smallest side, then you can look at the smallest one. Does that help? And you'll always know either the hypotenuse or the smallest side. It's not possible that both of those would be unknown. You have to know at least 2 sides. So you'll either have the smallest one, or you'll have the hypotenuse, or you'll have both. So far, so good? All right, let's go down and look at number 3. Number 3 says a summer camp is building a new zipline course. The designer of the course wants the last zipline to start at a platform 450 meters above the ground and end 775 meters away from the base of the platform. How long must the zipline be to meet the designer's specifications? All right, so let's draw this out. We have a platform that's up in the air. And how high is this again? 450 meters. And along the ground, we're going to go out how far? 775 meters. We are looking for the length of the zip line itself, so what you would take from the platform down to the ground. The platform and the ground should be forming a right angle with each other. If the platform and the ground don't form a right angle, then the platform is leaning and I wouldn't want to be climbing up on top of it. So we have a right triangle, and we can use the Pythagorean theorem to find missing sides of right triangles. Do we know the hypotenuse? Do we know what we would put in for C? No. I have a question mark there. What's something that I could put in place of the question mark that means I don't know this? Let's call that side x. So I'm going to put x in the place of C. And then what would I put in for A and for B? Yep, 450 and 775. So 450 squared plus 775 squared. All right, we're going to get some really big numbers here. What is 450 squared? And you can just read off the digits if you don't know the different place values. Yep, 202, 500. It's okay to just read the digits off. I know it's getting really big. It's 202,500. What is 775 squared? Yes, 600,625, 600,625. So when I add those two together, it's going to give me x squared. What do we get when we add those two together? What do we get when we add those two together? 803,125 equals x squared. I don't want my answer to be squared though, so how do I get rid of the squared on the x? Square root, and if you do it to one side, have to do it to the other side. So over on the right, the squared and the square root cancel each other out. I have the square root of 803,125. Let's see if we can simplify that radical. Square root of 803,125. So just looking at that number, it ends in a what? It ends in a 5, which means you know immediately that what can go into it? 5 can go into it. What is 803,125 divided by 5? Yes. So I'd have 5 times 160,625. Could 5 go into that? All right. So square root of, I'm going to bring this 5 straight down. But then this 160,625, I'm going to break that up into 5 times what? 5 times what gives me 160,625? Five times what gives me this? Or take this and divide it by 5. 32,125. These two light blue numbers multiplied together gives me that 160,625. All right, let's see if we can break this down any more. First thing I notice, though, is look at this. I have a 5 times 5 here. What do we do when we multiply a number by itself? What do we call that? Squared. So that's 5 squared. Times, can 5 go into 32,125? Yes, that'd be 5 times what? 6,425. Can 5 go into 6,425? Yes. This would be times 5. And then times, what is 6425 divided by 5? 1,285. Let me fix this here. Do you guys see where these numbers are going and where they're coming from? Which pieces are coming straight down and which pieces are being divided? All right, so I've got a pair of 5s again. So that 5 times 5 would also be a 5 squared, right? All right. So I have 5 squared times another 5 squared times 1,285. Can I break down 1,285? That'd be 5 times what? 257. Will 5 go into 257? No. Yeah, you get a decimal if you try to divide it. So to save us a little bit of time, I'll go ahead and let you know. 257 is a prime number. A prime number means the only things that go into it are 1 and itself. So I want to pull out anything that has a perfect square. So let me write this down over here so we can all kind of follow along with what's going on. I have 5 squared times 5 squared times 5 times 257. Any of these that have squareds, like this one and this one, I'm going to give them their own radicals. So it's the square root of 5 squared times the square root of 5 squared times, neither of these guys are squared, 5 times 257. What would happen right here? What is the square root of 5 squared? 5 squared would be 25. What's the square root of that? 5. So the square root of 5 squared is just 5. Times another square root of 5 squared. So the squared and the square root cancel, and that leaves me with just 5. Times, I don't have anything squared underneath the radical over here, so I'm just going to multiply those two back together. What is 5 times 257? 1,285. All right, and then to finish out my answer, what is 5 times 5? So x is 25 square root of 1,285 meters. Or, depending on the way the directions ask for the answer back, they might have asked for your answer back in decimal form. What do you get in decimal form if you go all the way back to here and do the square root of 103, 125? What is the square root of 803, 125 in decimal form? 896.172. And that would also be meters. So one of those two would be the way the directions ask for your answer back, but those are considered equivalent answers. Those mean the exact same thing. Let's flip the page over and try something else that is similar to that. All right, Lincoln Middle School is installing more wheelchair ramps around the school. One of the new ramps needs to have a base that is 12 feet long and reaches 1 foot high. If the side of the ramp forms a right triangle, how long should the inclined surface of the ramp be? So let's draw a picture here. So here's my right triangle. Needs to have a base that is 12 feet long, so that is the bottom, 12 feet, and reaches a height of 1 foot. So over here, 1 foot. And we want to know how long the inclined surface should be. So that would be this, the actual like ramp, what you would be taking a wheelchair or a cart up. All right, so let's look at Pythagorean theorem here. A squared plus b squared equals c squared. Which piece of this has to be the hypotenuse? X has to be the hypotenuse. It is opposite that right angle. So here's the hypotenuse. I'll put that in the place of c. So this would be x squared. What goes in for a and for b? 1 and 12, yes. 1 squared plus 12 squared. What is 1 squared? What is 12 squared? 144. What do we get when we add those two? 145 equals x squared. Is that my final answer? No, I still have a squared on the x. How do I get rid of that squared? Square root. And if you do it to one side, have to do it to the other side. So over on the right, the squared and the square root cancel each other out. Over on the left, I have the square root of 145. Let's see if we can simplify that at all. What do you know of that will go into 145? 5. 5 times what? 5 times 29. What goes into 29? Well then. That is very strange. Anyway, let's keep on rolling with what goes into 29 while I wait on the board to come back up. 29 goes into 29. What else goes into 29? What else goes into 29? Does anything else go into 29? No, 29 is a prime number. So can I simplify this radical at all? Can I find anything that's squared underneath the radical? Nope. So my final answer in exact form would just be square root of 145. So square root of 145 feet equals x. Or I can put that into my calculator, which I would like for you guys to do, and tell me what that is in its decimal approximation. 12.00 what? 4, give me one more. There we go. 12.041 feet. So again, you will decide how to give your answer back based on the directions. If the directions do not say, you're going to leave it in reduced radical form. If the directions say they want a decimal, then you'll put it into decimal form. So that you guys have time to see your tests from last week, I'm going to go ahead and shut things down right here. The homework that you picked up on your way in the door is going to be due on Wednesday. Homework is due on Wednesday.